Hello community! Wasn't this a beautiful keynote? We were told what to expect from the future. And we will have our Blackwell 200, our B200 here, the foundation of your AI Center of Excellence. But more important for coder is that we will have NeMo for customizing our LLMs, and now NIM for deploying these models, and for both here NVIDIA AI Enterprises here, the gateway. Now, if you're not familiar with NVIDIA's NeMo framework, simple, an open source toolkit, you create, you train, you fine-tune your AI model. Should be easier for developer, build advanced AI application, and it's done in PyTorch. The key features are, it's modular, you have a collection of pre-trained models, supports fine-tuning and in particular, you can upload custom dataset. This is interesting. And you know, with the new press release, now we have it here, NVIDIA Inference Microservices. Isn't this beautiful? And if you look at the very last line here, you can see microservices for retrieval augmented generation. And you say, hey, wait a second, are you sure? So let's check microservices for retrieval augmented generation. So if this is the focus now of NIM by NVIDIA, we say, okay, now we know what they're looking for here. And yeah, just 7 hours after the keynote, I had some ideas I published here in my community tab, and I said, yeah, NIM is part of the NVIDIA Enterprise AI software suite, where a strong use case for NIMs will be the support of the RAG deployment models. So this is NIM for RAG. But you know what's interesting is the partnership. And if you look here at Snowflake, and this is from 2023, and they said, hey, we want to run here our LLMs in Snowflakes to use them in conjunction with Snowflake data and Snowflake container services. Beautiful. And now, you guessed it here, now in March 2024, we have now extension of this partnership from Snowflake plus NIM. So if you buy the NVIDIA hardware, you get the NVIDIA software suite, the NVIDIA Enterprise Edition, AI Edition, with your hardware machines. Now, isn't this beautiful? And then you can run all of this within, for example, Snowflake. And as mentioned here, you know, NeMo here, the framework crucial for fine-tuning pre-existing LLM or developing new LLMs from scratch, using here the vast amount of enterprise data stored in Snowflake. So Snowflake says, hey, you can stay within our boundaries, protected by our cybersecurity. You do not have to reach out somewhere else here to do the computation. We, in our data centers, we have NVIDIA, we have here the Blackwell 200, we have the super chips, and we have here the NVIDIA Inference Microservices to fine-tune everything, and you can do whatever you want. You don't have to leave Snowflake, for example. So if you're a company that can afford to buy the NVIDIA product, you clearly see here the value proposition from NVIDIA to all the companies in the world. For example, here you stay within the secure environment of Snowflake's data cloud. Now, since this is not a sponsored video, please exchange Snowflake with whatever data provider you like. But this is just about the idea what is happening. Hardware and software become standardized. And if you buy this, you can integrate it here within your enterprise. So NVIDIA AI Enterprise is the gateway for every developer, for every coder, for everybody who wants here to customize large language model with their company data and then deploy this large language models here with microservices from NVIDIA NIM. So you see a beautiful new world. Everything is standardized. Everything is available from NVIDIA, from the NVIDIA hardware machine, the NVIDIA software packages, and the NVIDIA technology to make it run on a node or multiple node of NVIDIA Blackwells. Now, isn't this beautiful? Yeah, and maybe there were some independent coder, some independent developer, but let's talk about the beauty first. Now, of course, you might say if you want to be a professional, maybe you go to this NVIDIA developer page where you have the tutorials, you learn about everything that's going to happen, and maybe this standardized software, this standardized hardware that goes together with NVIDIA is the way forward if you want to be an enterprise AI engineer, coder, developer, whatever you want to be. So you better get up to terms with NVIDIA. And just to show you this, even yesterday, March 18, we have here from Hugging Face. Now you can easily train your models that you have on Hugging Face with the H100 GPUs on NVIDIA Cloud Services. Now, isn't this fantastic? So even now here, Hugging Face gives you, if you have the Enterprise Hugging Face Edition, then you have here access and you can pay here for NVIDIA Cloud and the H100 GPUs directly from Hugging Face. So I think you see the signs of the time. And I just would like to recommend this article here, March 18. Hugging Face easily train your models with H100 GPUs on the NVIDIA Cloud. So you have here cooperation NVIDIA with Hugging Face. So the GPU poor, like I am, they are no more, according to Hugging Face. Beautiful. So Enterprise Hub organization can give their team instant access. So you have to have an enterprise account with here our beautiful Hugging Face, and then you're allowed to pay and you get access to here our cloud services. Let's have a look how it works. You have a Hugging Face Enterprise Edition, beautiful, and you pay for this. And you go to Hugging Face and you have your Llama 7B. And here you see you have your train, your auto train, your Amazon SageMaker, or your NVIDIA Cloud. And you go, of course, here to the NVIDIA Cloud. You select your organization with your organization account. They go, of course, here, being from Hugging Face with their Hugging Face account. They click here on Create New Space. They give you exactly what you have to do. And once you are in the auto train space, you can create your training job here, configure your hardware, your base model, your task, all your training parameters. You can do everything here according here to the presets that are allowed that you are using here. And then you have here, for example, your base model Mistral 7B. Beautiful, your starter training. You can have 1 or 8 H100 GPUs, and it just depends here. And you can start the training by clicking Start Training. Now, this is amazing. Now, and you can monitor the training by opening here the logs of the space, and you see exactly where you are. Pricing is, I would say, yeah, it's a little bit expensive, but if you have an Enterprise Hub organization account, and you have one NVIDIA H100 with 80 gigabytes, you pay about $8.50 per hour. Okay, and the Hugging Face says we are just getting started. Collaborate with NVIDIA. So you see, everything is moving to NVIDIA Cloud, and this is it. The NVIDIA machines are there. And if you are a developer, maybe you should get familiar with the NVIDIA ecosystem, because maybe a lot of companies are gonna use those standardized approaches of a combination of hardware and software. For more information, why not go directly to Hugging Face and check? I'm sure in the next days they will have some further information for you. So let's come back and says, now NIM is part of NVIDIA Enterprise AI software suite, beautiful. And they are in support for the RAG deployment model. So let's talk about NIM RAG. And everything is beautiful, everything is standardized. We have NVIDIA and it's a beautiful day. However, and you might ask, yes, Professor, what do you think? What is on your mind? And I might say, you know, there was a tiny little bit of information, because on Tuesday's NVIDIA Q&A session, Jensen was asked what you do about AI hallucination. You know, this strange little scientific thing here, the tendency for AIs, for LLMs, for RAG system to make up answers that sound plausible, but aren't based in fact on pure hallucination, pure nonsense, wrong factual data. And Jensen appeared to be visibly frustrated by this question. How could you dare to ask here this in an official Q&A session? But you know what? Thanks to TechCrunch here, we got this from Jensen. He said, you know what? Add a rule. For every single answer, you have to look up the answer. Examine the source and the content. Compare the facts contained in the source to known truths. And you know, hey, this is easy for us humans because known truths, I have my known truths. If you watch television in the US, you know, you have CNN and this is your known truth. And if you are in the US and you watch Fox Entertainment, you know, this is the known truth. So you see, we as humans, we have no problem at all to have known truth. But this poor little AI system here, does it know what are our known truths, our individual known truths? And Jensen goes on, if the answer is factually inaccurate, even partially, discard the whole source and move on to the next one. Don't answer this question. And now comes something from Jensen that I love. The AI, so our LLM, our RAG system, our microservices, shouldn't just answer. And you might say, but this is the topic of a large language model. No, I have a query and I get an answer. No! Now, today, we learn, Jensen tells us, the AI should do research first to determine which of the answers are the best. I say, okay, Jensen has to know it. He has millions of GPUs, so he is the person to go to. So AI should do research first. And then we have a lot of answers, a set of answers, maybe an infinite amount of answers. And then the research will tell us which answer is the best one. And, you know, somewhere in my brain there is this little voice and says, are you sure the LLM should do research first? I mean, research? Haven't we not trained the LLM and the RAG system and everything from a vision language transformer system that it learns something so it has the knowledge and it can apply the knowledge? And now we tell, hey, we don't trust the system. The system should do research first. And this from Jensen. So let's do this. And you say, hey, no problem at all. You know, February 2024, we have the corrective retrieval augmented generation. And I showed you this here in my video, Simple Ideas to Improve RAG from Stanford and Google. And I went through this C-RAG and how you can apply it and what are my insights into C-RAG. But of course, you have seen here my video from 4 months ago about self-RAG, a self-reflective, almost aware retrieval augmented generation that constantly checks its own processes, you know. But self-RAG, yeah, it's 4 months old, so is it doing research or is it just controlling, supervising, augmenting itself? And then comes something beautiful that I really love, and Jensen says, hey, for mission-critical answers, so if it really depends on this, such as health advice, so if you're in biotechnology, bioengineering, or just in medicine, the NVIDIA CEO suggested perhaps checking multiple resources and known sources of truth is the way forward. So, ladies and gentlemen, there you have it. This is the way forward. No question asked. So you check multiple resources, CNN plus Fox, and known sources of truth. This would be, yeah, okay, and known sources of truth. Don't overthink this, and this is the way forward. Perhaps. So here's our solution. Congratulations. And you know, this little voice here, way back here in my mind says, where is Stanford if you need them? And you know what? Stanford is here, Stanford University, on the very same day, March 18, 2024, published here the solution. And you're amazed. I knew you were amazed because it's a QuietSTAR. This is a new methodology that language model, our LLMs, can teach themselves to think before speaking. And you would say, hey, this qualifies here as doing research, no? This is, of course, something here happening at the exact same day, 2 hour GTC 2024. So here we have it. And you say, I hope it is really research. You say, I hope this is really something complicated for research, for science, and not just some simple algorithm. And if we look at the algorithm, you say, okay, yeah, this looks, the hex, hidden states, the mixing, the log, the reinforce, and this looks here as a nabla operation here in a mathematical space. Okay, let's say this is research. Can somebody explain this to me? Because if I look at this, I have no idea what this is all about. But hey, it's Stanford, so come on, let's chill and relax. And since it's a QuietSTAR, we have to look back in history to the original star, the self-taught reasoner, bootstrapping reasoning with reasoning. And sometimes you feel a little bit strange when you do AI videos on YouTube, but never mind, here we go. So May 20th, 2022, we had here beautiful Department of Computer Science, Stanford University, and Google Research. Hey, what a coincidence. And here you have the simplified star, the original star algorithm. And you look at this and say, hey, now I immediately understand what they are talking about. But if you are not that advanced, I have here some slides for you because I had to go the long path. So, star, simply improving the ability of LLMs to perform complex reasoning tasks. And this is achieved by generating step-by-step rationals. And you say, we know this. Of course, it's from 2022. So LLMs, when trained to generate explicit rationals, or maybe you know this, under the name chain of thought processes, before arriving at a final answer, exhibit better performance and a better generalization ability, especially in complex reasoning tasks. And we know this. The nice thing is that there's a bootstrapping. So it introduces a novel bootstrapping mechanism that iteratively improves the rational generation by learning from a small initial set of examples where you have exactly the data. This is the task, and here I show you how you can argue what is here the step-by-step guidance. And from this small initial set of examples, the system, the LLM, improves, and every run gets better every time it executes this exactly task. So it goes over the limitations of learning only from correctly solved problems, from in-context learning. Now it is able to learn itself. Includes a backward reasoning approach, enriching the training data set and the overall model performance. And it is something like a little bit of a self-improving LLM. And this self-improving mechanism opens new pathways for developing more autonomous and efficient AI systems. Isn't this beautiful? So what we have, a small set of examples with given rationale, in a given topic, in a given structure. And this will be the patient zero to teach the model to self-generate high-quality rationales, going through this process multiple times. Beautiful. You might ask one example. Here, simple example. Question. What can be used to carry a small dog? And the choices are given here. A pool, swimming pool, a basket, a dog show, a backyard, and their own home. And now you want the model to be transparent and says, hey, show me your rationale before you answer. And the rationale of our LLM is, to carry a small dog, the object must be portable and designed to hold things securely. A swimming pool, a dog show, a backyard, and one's own home are not designed for transporting objects. Among the objects given, a basket is specifically designed to hold and carry items, including potentially a small little dog. So baskets are portable and come into various sizes, making them suitable for carrying a small dog comfortably. Then, given this rationale and this argumentation, the system answers, therefore the answer is B, the basket. This is what we mean with rational, and if the system learns more and more complex rationales, this is the way forward. It is important to have this because it generates insight into the decision making. We can see here with the debugging clearly the errors that are happening in the model reasoning structure. We have more trust if we understand how an AI system builds up its rationale for the decision. And if it is a self-learning system, it can better generalize for more advanced reasoning abilities that might come up in the future. And you say, hey, beautiful, so STAR? Why is STAR not everywhere? Let's go back to QuietSTAR and let's see how Stanford University improved on STAR in 2 years. Let's look at this. Can you see it? Yes, you know what I mean? Now, what they did is massive parallelization. So I have a token-wise parallel sampling algorithm using learnable tokens indicating the start and end of a sort of a rational and an extended teacher forcing technique. And you might say, what is this? Let me show you in a second, but before tell me the performance of this system. You might have read here in some publication that QuietSTAR is an improvement of 100%. And it is true, but know the data. So the authors found here zero-shot improvement on a particular benchmark set from 5.9%. And it increases with QuietSTAR to 10.9%. And for some common sense question and answer data set, it moved up from 36% to 47%. Now, I don't know about you, but if I have a mathematical benchmark with a rate of 10 or 11%, or a common sense Q&A with less than 50%, I would be a little bit careful to say that this is an AI breakthrough. In particular, they have some interesting way to structure this. So, at first, understand that they generate rationals after every token. And I really mean after every single token in the input sequence, they generate a rational. To explain here the future text, this is what they call the thinking process. Then they mix here the future text prediction with and without the rationals. This is what they call here the talking. And then learning to generate better rationals using here the reinforce mechanism, the learn phase. And if you look for the reinforce mechanism, you find it here in 1992. And yes, it was a reinforcement learning for a statistical gradient following algorithm. This is here the original idea here from 1992. Beautiful. How does QuietSTAR work? And it is no joke. It is really taking every input token and generating a sort. And you see here the LLM generates a sort and the LLM generates a sort for each and everything. Think, talk, learn, but let me give you a better explanation of the 3 phases. So 3 main steps. You have at first a parallel rational generation. So in parallel across n tokens, xi, in an input sequence x from 0 to n, we generate r rationals of a specific length t, resulting now in n times r rational candidates. Then we insert some particular tokens, the start of a sort token and the end of a sort token, to mark here where it ends and starts. And then from the hidden state output, after each rational for each token, we have a mixing head. This is just a shallow multi-layer perceptron producing a weight. And this weight determines how much of the post-rational next token predicted logits should be incorporated compared to the base LLM predicted logits. Easy. And then you have the third step. You optimize here the rational generation parameters. Think about hyperparameters to increase the likelihood of rational that make future text more probable. So this is an interesting aspect. It just does not look to the next token, but it goes beyond the next token. It looks more into the future to generate here rational generating parameters with an extended reach if you want. And then they use here this reinforced learning, this reinforce to provide here a learning signal to rational based on their impact on future token prediction. This is a nice way. So for our green grasshoppers, there's 3 phases here in a more simplified version. So coming back, we can state that Stanford generalized the classical STAR methodology to learn now reasoning, self-reasoning from some diverse unstructured text data. So you do not have to provide learning examples. You just give it, I don't know, the content of the internet. There you have it. And then you decide how to start reasoning, having unstructured textual data. This is an interesting way. So, as you remember, the first step was parallel generation here. And this is efficiently generate rationals at each token position in the input sequence. And they do this with a little bit of an optimization. So they allow for a highly parallel generation by first observing that an inference pass of an LLM produces a probability distribution over the next tokens for all input tokens. And this allows them to sample one next token from each token in the input. And they cache here the forward pass and concatenate a diagonal attention mask to the previous attention mask. So each generated token now attends to all of the tokens that were used to generate it, as well as add to itself. So have a look at the original literature. This is a nice methodology doing this with attention masking for the future tokens. But let's have a look at the results. What is the end result of after applying all of this beautiful, extreme, complicated research that an LLM should do, given Jensen advice? Now, because this augmentation or chain of thoughts are themselves generated by simpler chain of thoughts, one might refer to this as a net of sorts. So if you see net of sorts, you know, chain of sorts generate more complicated chain of sorts, and they have a rigorous effect on the other chain of sorts. And my goodness, so they compare here 5 solutions from the model with a fixed random question from a particular benchmark. And the LLMs that they use is a simple Mistral 7B. And yes, you guessed it, Stanford visibly cannot afford to use a more expensive model. So we go with a 7B for causal reasoning and self-training. My goodness, and now you understand why we go from 5% to 10%. But anyway, the methodology is interesting. And the output of the Mistral fine-tuned for the same number and steps on the open web, map, data, and beautiful, beautiful. So here we have it. Now, the task is easy. We have Janet's ducks lay 16 eggs per day. She eats 3 eggs for breakfast every morning and bakes muffins for her friends every day with 4 eggs. She sells the remainder at the farmer's market daily for $2 per fresh duck egg. How much in dollars does she make every day at the farmer's market? And we apply now all what I just told you, the complexity of a system that has been pre-trained and fine-tuned and QuietSTAR trained here on a Mistral. This QuietSTAR. And this here is the first response. So out of the box, we get from a Mistral 7B, and you know I like a Mistral 7B. Okay, 16 eggs per day, 3 eggs are eaten for breakfast, 4 are taken for muffins, so 16 minus 3 minus 4 equals 9. 9 of the eggs are sold at the farmer market at $2, so $18. Right out of the box. And then you go to the 5th response. We have the duck lays 16 eggs per day. This is the total number of eggs. Then we have an operation 3 plus 4 plus 16 equals 23. And it's a little bit surprising because if you think about this, what is this? And then correct statement, 3 eggs are eaten. Yeah, 4 eggs are eaten for muffin. And 16 eggs are sold at the farmer market for $2 each every day. No, this is wrong. Because the duck lays 16 eggs per day and 3 are eaten and 4 eggs are gone for the muffins. So this is nonsense. And why we have to add here the number, this is nonsense too. And then we have a statement, hey, the 16 eggs that are sold at the farmer's market are the remaining eggs. But that's nonsense because the duck lays 16 eggs per day. So this is wrong, this is wrong, this is wrong. But then somehow the system It's coming back and says, hey, maybe I do here another mathematical operation. So 16 minus 3 minus 4 is 9. 9 times $2, so $18. So you see, seeing here now the way that this LLM on this RAG system here, the G and the RAG, thinks about deducting here causal augmentation, I know I would not trust here the fifth response of the system, because 16 eggs are sold at the farmer market for $2 every day is simply wrong, and this is also wrong. So luckily, sometimes it jumps to the correct path, but this should not be an answer. So like Jensen told us, choose from the multiple set of answer the right answer, given that you know the truth. My goodness, what a genius. So you might say, hey, is overthinking that the system learns to get more and more complicated in its causal reasoning for LLM or for the generating in a RAG system? Or is it just because the Mistral is in itself not the right LLM for doing causal augmentation? And I think it's kind of both. 7B is current state of technology, not the right tool, not the right LLM to do this complex self-teaching, self-learning causal augmentation pathways. And the overthinking here is just wrong, just nonsense. Yeah, and then, you know, my good old ChatGPT-4 Turbo Super Beautiful. And I just put in here the query here in GPT-4, and it comes up here with equation, tells me everything. GPT-4 just starts here the Python environment, calculates here for this equation here with the number here, the correct result. And the result is Janet makes $18 every day at the farmer market by selling the remainder of her duck eggs. Beautiful. So here you have it again from NVIDIA's CEO, the person who knows everything. For a mission-critical answer of your RAG system, your triple augmented generation, or if you just use an LLM as an agent, or you have multi-LLM agents working and lying to each other, if you are mission-critical, perhaps check multiple resources and the known sources of truth, and this is the way forward to do NIM and NIM RAGs. Ladies and gentlemen, as always, it was amazing. I hope to see you in my next video. And in my next video, I show you that we can forget supervised fine-tuning. We have something better to train our LLMs.